episode, we're looking back at one of the most active periods on the Sun. We're returning to October 2003, well into the declining phase of solar cycle 23. October started very quiet, but with little warning, 3 large and intense sunspot regions emerged. These regions produced 17 major flares, including some of the strongest flares ever recorded by the cruise satellite. These flares caused some extreme geomagnetic storming, with Aurora that could be viewed as far south of Florida and Portugal. Because the extreme geomagnetic storming occurred around Halloween, the storm is now known as the famous Halloween storms of 2003. And this year marks the 10th anniversary of that period. Let's take a look at the active regions, and we start with Sunspot region 484. Region 484 rotated on the solar disk on October 18th at a size of 200 millionths. In less than a day, this region grew rapidly to over 1,000 millionths and also an increased magnetic complexity. From 20 to 22 October, this region continued to increase in size and magnetic complexity, reaching an area of 1,750 millionths with multiple delta configurations within one large p-numeral area. As region 484 transited the central meridian, it began to slowly decay, decreasing to 1,250 millionths by October 29. The region rotated around the west limb on 31 October. Throughout this gradual decay in sunspot area coverage, the magnetic complexity did not appear to diminish. Multiple delta configurations were evident until the region transited the west limb. Despite the size of this region, it only produced 2 X1 flares, an X1.1 on October 19th and an X1.2 on October 26th. Next region, region 486, announced itself days before it was visible on the solar disk, with some major CMEs that were observed behind the southeast limb. The region rotated onto the visible disk on 22 October and was fully into view by October 23. Unlike region 484, this region was already very large and complex from its first appearance. Although it was already a very large and complex region, it was still in a phase of growth and continued to develop over the next 6 days, reaching its largest size of 2,610 millionths by October 29 and becoming the largest sunspot cluster of the 23rd solar cycle. On October 27th, region 486 developed an east-west corridor of negative polarity through a positive polarity. Significant magnetic shear evolved along an extended complex inversion line. As a result, 2 of the largest X-ray events, an X17 and an X10 on 28 and 29 October respectively, occurred just after this east-west inversion line was formed. Region 486 began a slow decay on October 30. However, a tremendously complex magnetic configuration persisted through the remainder of the region's visible disk transit. And just when it rotated off the disk, on November 4th, it produced an X28 solar flare, which was the strongest solar flare ever recorded by whose satellite. It rotated eventually on the west limb on November 5th. The region continued to produce powerful CMEs for several days after its exit from the visible disk. Region 488 was a new region that appeared 22 degrees off the eastern limb on October 26th. From the few spots that emerged on October 26th, it grew very rapidly in the days ahead. With the very fast growth phase, the region also developed significant magnetic complexity, and on October 28th it had a beta-gamma delta magnetic configuration, and it persisted for the remainder of the disk passage. Region 488 reached a maximum area coverage of 1,750 millionths on October 30th. A slow decay began on October 31 and continued until the region transited the west limb on November 4th. This region only produced 2 major flares, because of the limited compactness of the intermediate spots. Major solar activity began on October 19th when region 484 produced an X1 flare. As region 486 rotated onto the disk, region 486 produced an M9 flare on October 22. A complex filament eruption near region 484 occurred on October 22nd. This coronal mass ejection arrived on October 24th, which produced a strong geomagnetic storm up to the G3 level. Region 486 continued to produce major flares on October 22nd to October 24th, with 2 X-class flares and an M-class flare. On October 23rd, an X5 flare occurred and showed a full hollow coronal mass ejection, although the CME was not Earth-directed. The second X-class event on October 23rd was an impulsive X1. In the early hours of October 24th, region 486 produced an M7 event. LASCO observed a coronal mass ejection that was not directed towards Earth. On October 26th, both region 484 and 486 produced major flares. Region 486 produced an X1 event. LASCO imagery indicated a partial halo CME. Later that day, region 484 produced an X1 event and a full hollow coronal mass ejection was observed in LASCO imagery. This flare was also the source of an energetic particle event and a shock that was observed at ACE satellite on October 28th. While the X-ray levels were declining from the second X1 flare, an impulsive M7 flare erupted from region 484. On October 27th, region 486 produced 2 major M-class events. First, an impulsive M5 flare, the second was an M6 flare at 1 o'clock. But the most significant solar activity began on October 28th at 11 o'clock. An X17 flare occurred from region 486. Very fast full halo coronal mass ejection was clearly visible in LASCO imagery with a plane of sky speed measured at 2,100 km per second. The flare produced a proton event that exceeded the 1000 PFU level, that's an S3 space radiation storm, within an hour of the flare, and the S4, an extreme space radiation storm, 13 hours after the flare. The coronal mass ejection associated with the event arrived at Earth on October 29th, shortly after 6 in the morning. It took the CME only 19 hours to travel from the Sun to Earth. It was the fastest CME Sun-Earth transit of solar cycle 23. The geomagnetic storm that followed reached the extreme levels and lasted for 27 hours. Region 486 produced another major flare on October 29th. An X10 flare erupted. The CME associated with the event was clearly visible on the LASCO imagery. It was a very fast full halo CME with a speed over 1,900 km per second. The transit time for the CME was also 19 hours, arriving at Earth on October 30th in the evening. The geomagnetic storm from this CME lasted for more than 24 hours and reached extreme levels. Activity was relatively quiet until November 2nd, when region 486 produced yet another major flare. It was an X8 flare. LASCO imagery indicated a full halo CME with a plane of sky speed measured at 1,800 km per second. The sun impulse was observed at Earth on November 4th. A brief geomagnetic storm followed. Before turning around the western limb, region 488 produced two major flares. The first flare was an X2 event with an associated partial halo CME that was visible in LASCO imagery. The second flare from this region was an X3 event with also a partial halo coronal mass ejection of the northwest limb. But the most intense and powerful solar event took place on November 4th in the evening. It was an X28 flare from region 486. The GOES XRS instrument was saturated at X17 for more than 12 minutes. Using historical flare data and mathematical modeling, the peak flux was estimated to be an X28. This flare is likely the most intense flare observed since 1976, when the GOES X-ray measurements of solar flares began. LASCO imagery indicated an associated full halo CME, measuring a plane of sky speed of 2,400 km per second. Despite the record size of the flare and high speed of the CME, its location near the west limb of the Sun limited its impact on Earth. The center of the CME was directed off the southwest limb and was observed as a glancing blow at Earth. Minor storm conditions were observed for a brief 3-hour period on November 6th. A moderate proton event associated with this flare lasted for about 3 days and ended late on November 7th. The last major flare of the period was an impulsive M5 event that occurred on November 5th. Powerful eruptions continued for over a week after region 486 and 488 rotated around the west limb. There were 5 discrete transient-related geomagnetic storms during the period of October 19th through November 7th. These included the 6th and 16th largest geomagnetic storms on record since 1932, based on the Potsdam 24-hour running AP index. The storm's onset on October 24th followed a 105 nanotesla sudden impulse on the Boulder magnetometer at 3:30 in the afternoon. The source of this event was a complex eruption on October 22nd near region 484. It took the CME almost 60 hours to travel the Sun-Earth distance. The direction of the interplanetary magnetic field was southward for a brief period following the Sun impulse, but quickly rotated into a prolonged strong northward orientation. The highest global K index observed during the storm was 7. The storm that began early on 29 October was the 6th largest geomagnetic storm on record based on the Potsdam running AP index. The CME that drove this storm was associated with the X17 flare from region 486 on October 28th and arrived less than 19 hours after the flare. The coronal mass ejection arrived at Earth on October 29th and a 140 nanotesla sudden impulse was observed on the Boulder magnetometer just after 6 in the morning. Solar wind speeds near 2,000 km per second and the direction of the IMF as peaking as low as minus 50 nanotesla caused a significant geomagnetic response. Storm conditions quickly elevated to extreme G5 levels. Around 9 in the morning, the direction of the IMF went sharply north and stayed that way for almost 10 hours. Storm levels stayed at or above a global K scale of 7 for the duration of the northward directed interplanetary magnetic field. This was largely due to the extremely high speed of the solar wind that was buffeting the magnetosphere. Around 6 in the evening, the direction of the IMF rotated southward to near minus 30 nanotesla for several hours and storm levels were again in the K index range of 8 to 9 on a global scale. The aurora was visible overhead from latitudes as low as Belgium and was also visible on the horizon as low as Texas in the USA and Spain in Europe. The storm gradually weakened to minor storm levels early on October 30th. The return to relatively calm conditions was however short-lived, as another fast and powerful coronal mass ejection was about to arrive. A shock driven by this coronal mass ejection associated with an X10 flare that erupted on October 29th was observed by a satellite at October 30th in the late afternoon. It took the coronal mass ejection only 19 hours to travel from the Sun to Earth. A long period of strongly southward directed interplanetary magnetic field followed after the impact, reaching as low as -30 nanotesla. The global K indices reached severe to extreme storm levels in the first 6 hours after the impact. Aurora was again seen on latitudes as low as California in the USA and Austria in Europe. Around midnight on October 31st, the direction of the interplanetary magnetic field went again northward. Even with the northward directed IMF, the high solar wind speed still produced moderate to strong geomagnetic storming. A full hollow coronal mass ejection erupted from the Sun associated with an X8 flare on November 2nd. A shock impacted the A satellite around 6 in the morning on November 4th, that's about 37 hours after the flare occurred. The speed of the solar wind increased to almost 800 km per second. The direction of the interplanetary magnetic field maintained a mostly northward orientation up to 20 nanotesla for the first few hours and turned south around 9 in the morning. This resulted in one 3-hour period of strong geomagnetic storming. Around 10 in the morning, the direction of the IMF went northward again and no more geomagnetic storming was observed. The powerful X28 flare on November 4th produced an extremely fast coronal mass ejection of the southwest limb. Though a full halo CME was identified on LASCO imagery, the center of the CME was not Earth-directed, but a glancing blow was to be expected. This coronal mass ejection from the X28 flare reached the Earth in the evening hours on November 6th. The solar wind velocity jumped from 500 to 600 km per second and the IMF increased in strength to 15 nanotesla with a slight southward component up to -10 nanotesla. Geomagnetic activity reached minor storm levels for one 3-hour period with a maximum K index of 5 on a global scale. So this concludes our special video about the Halloween storms of 2003. If you don't want to miss a thing about space weather, solar activity or geomagnetic activity, keep following us on Facebook and Twitter, and of course on our website spaceweatherlive.com.